My name is Justin Leet. I'm with Hortonworks, currently with professional services, but pretty soon I'll actually be on the Metron engineering team, which I'm looking pretty forward to. So what I'm going to talk about today is actually kind of a lot of just the getting into Apache Metron. So unfortunately, unlike Hive or Pig or anything else that everybody's seen a million times, I'm going to have to spend a little bit of the presentation kind of making sure everybody's on the same page, making sure that they know what Metron is even to begin with. But after that, we're going to dig into a little bit of how some of the architecture works and basically do a pretty much hello world type little mini walkthrough of kind of just bringing a source up through Elasticsearch. Probably not really going to have time to do anything much more than that. I know we've set up like a demo booth with a lot of the Kibana stuff to be able to dig into that. But the goal is kind of to actually get to dig in and give everybody a little taste of what happens and let them see how things carry through. So obviously, like I said, the first thing is what is Apache Metron? You probably heard it if you were at the keynotes yesterday. Capital One brought it up that they're using Metron. Basically, long story short, per the Apache Metron kind of incubator page, it's an Apache incubator project. It is a security analytics platform. It's in the very, very early phase. So there's still a lot to be built. It's real benefits over other things like Splunk, or we're building in a lot of extensible like plugins. We want you to be able to pull up a lot of different sensors, bring them all in, have them all be normalized, have them all be enriched, have them pass through analytics and eventually some machine learning algorithms, which is kind of one of the other major focuses is we don't want you to have to depend on static rules. Those get outdated, those eventually fail over time just because attackers always try to defeat your defenses. So that's something that's being worked to. A lot of the groundwork is being laid for that right now. So kind of the timeline of this is a couple years ago, there was kind of the OpenStack beta that was built by Cisco in collaboration with Hortonworks. Eventually, this kind of gets released in the community edition, but it doesn't pick up a whole lot of adoption. And eventually, it makes it into Apache Incubator as Metron. And then a lot of work has been put on it over the past few months. The first release was actually in April, just a couple months ago, kind of getting a lot of things working, kind of starting to pull everything together, build a good foundation, re-architect a couple things. And then as we've progressed over the last couple months, there has been a vote on the dev list for actually building towards a 0.2 release. And a lot of that 0.2 has been a lot of usability, like kind of ease of use stuff. There's still a long way to go. Building better ways to interact with it, easy ways for people to spin this stuff up right now, easier ways to install it. But like I said, it's very much a fledgling project. I've tried to reflect a lot of the 0.2 changes in here. But some of it's things that I haven't quite been up to speed with as they've kind of trickled in over the past couple weeks. This is a 2-month turnaround for this, so blink and you miss it for some of this stuff. But luckily for us, for our discussion, a lot of it is upper level things. There's some quality of life things, like some domain specific queries you can make, and a lot of work went into the Kibana UI, so the moved from 3 to 4. But really, to understand Metron and OpenStack, it's a lot of, who is this actually intended for? So there's a few different people, personas. You'll hear kind of users, personas, and so on, kind of all around this of who actually wants to use this. And really, we're going to be focusing on couple of these roles in terms of like just making this data available. So specifically, probably most saliently to our conversation is the SOC analyst. So this is kind of the front lines person who will be taking tickets based off of these anomalies, will be investigating them, who right now they will get an alert and they have to dig in, they have to look at the alert, they may have to go back and get the raw data. They may have to go into machines. They may have to go reach out to a couple different resources to even get useful information to be able to make a determination on what the next steps are. So a lot of what Metron is built around, at least what's available right now, is a lot of enrichment activity, which we'll start to dig into as we go on. Some of the other people kind of involved, just so that we're all kind of in the same space of what we're looking for, is like the SOC investigator, so kind of one step above the SOC analyst. If we have to dig in a little more, they're going to be the person kind of doing a lot of that. Obviously, there's going to be some management of this team, so they're looking to make things go faster, go smoother, go more accurately. The higher accuracy you can get, the faster you are, the happier everyone is, and the safer everyone is. Like forensics investigators, so a little bit after, like, say, initial contact settles down is when someone actually digs in, and they may be digging into a lot of kind of the surrounding, how did this happen, what happened, what do we need to do going forward. Security platform engineers, Metron runs on Hadoop. It uses a lot of the components of the stack. There's a lot of Storm topologies. Typically, you're going to be using Kafka as your kind of buffering lead-in mechanism. If you want to pull in a lot of these logs, you're probably going to be looking at Apache NiFi to bring them into Kafka. HBase is the backing store for a lot of things, and we'll dig into that a bit more later. But you're going to want to be able to support this. Everybody's going to want to be able to understand, work with it, have some kind of expertise of what this means to actually pull everything together, and kind of data scientists. So as we are concerned with not just things streaming through, we may want to look historically to kind of see what types of anomalies we've seen, build new models to train them, and actually let those models be applied over streaming data so that we can assess them and actually get a better idea of what we're looking at without being dependent on those static rules that we were talking about earlier. So Metron's core capabilities kind of fall into 4 buckets. We're not going to spend a huge amount of time on these, but I just kind of want everybody to be a little bit in the know of them. So when I was alluding to the data scientists looking through historical data to build models, there's a lot of talk about security data lakes or security data vaults. This data is persisted in Hadoop and made available for historical searching, in addition to the real-time applications that go through and get applied. So it is available to actually do deeper digs into that are a little bit beyond or a little bit discovery oriented for what you're actually trying to build later. There's a big effort to make things extensible. There's a lot of plug-in points. If you want to add new sensors, you can define a new parser, do normalization on that. If you want to add new enrichments, you can go ahead and add new enrichments. New threat intel, you can go ahead and add. And this is something that we're going to be looking to the community a lot to help us build, because everybody has very different approaches to this right now. Everybody uses a little bit different data sources. Some of these are going to be even custom in-house that may provide value for the community to see, be aware of, enhance, kind of pool common use cases, or enhance existing use cases that show up for pretty much everyone. Other than this, there's threat intelligence. When we actually see something come through, we want to be able to act on it. We want to be able to assess it. We want to be able to apply either rules or machine learning to it, and we want it to actually be actionable data. It's no good to anybody if everything's just coming through and either nothing gets applied or too much gets applied. And finally, this is a security-focused application. There are things like PCAP replay and so on. A lot of packet capture stuff is in here. It's going to be a little less what we talk about. But really the goal is to be focused on security, to provide that viewpoint into things, kind of provide a lot of a pane of glass to everybody to look through so that they can very quickly and easily get what they're looking for. So When we talk about architecture, what I'm actually going to be talking about is, like I alluded to earlier, is basically how do I go from my sensors to Hadoop and Elasticsearch. So basically, really, this is, like I was saying, a lot of these sensors, these might be just various logs. These might be either like proxy logs, like Blue Coat logs. They may be Bro logs. They may be whatever type of information that you want to pass through and actually have analyzed, or kind of even grouped with other data sets that you want to enrich with. These are going to get landed in Kafka. This is kind of where the domain of Metron actually enters. How you get it to Kafka, that's kind of, to a large extent, up to you. This is where we start looking in. In a lot of cases, for NiFi is going to be a really good fit here. I'd recommend taking a look at it. I know, for instance, during Joe Nemec's talk yesterday about NiFi in the home, he was actually talking about how they were seeing a lot of pings to their router from, and I apologize if I slander a couple countries that I shouldn't. I believe it was Portugal and China that they were seeing pings on constantly. So they were taking a lot of NiFi data from actually the router anyway, moving it up, kind of gathering it, doing doing some kind of analytics and stuff on it, and they were moving it right to be available with Kafka. So it's like a good fit for that. Once we kind of actually have everything landed, there's basically a set of topologies that will be spun up for our sensors that know how to understand and deal with the data in them. I'll actually dig a bit into a very basic sensor a little while later, but we're going to spin up essentially one of these topologies for each sensor. Each topology is going to read from one topic per sensor. Everything is going to carry through nicely there. They will get parsed. They will get normalized, cleaned up a little bit into a useful format that carries through their attributes, and make sure that we pull out things like IP, the source IP, what sensor it is, make sure kind of the basic tagging stuff we want is there, so that we have a consistent data set to look across when we're doing enrichments. All of these will feed to an enrichment topic. Everything's basically, I don't want to say uniform when we get here, but everything has the same, set of common core attributes that we can actually start looking at. So enrichments might be, we want to start doing some, pulling geo-IP information based on these. Potentially, you could build something for like who-is information if you wanted to be able to make these queries. Typically, these enrichments are pulling off of HBase. We'll dig into, what that looks like a little bit later in each of these topologies. And when we actually make it to the enrichment topologies, these will look at each piece of data, and they will, start pulling everything in, append new fields to the data, and kick it out to our data vault in Hadoop, and also make them available to Elasticsearch so that you can actually, query and look at these, play around with them, which is what we'll see a little later. So in terms of parsing, there's basically two ways we can actually configure these. This is, the old regime was basically you had to build a Java parser for everything. You had to pass these things through a Java parser. Now there is a grok parser available. This is basically a regex-like syntax. This is going to be a lot easier to quickly spin something up, see how things work. It's very easy to use. We'll actually be seeing an example of this later, and it's very readable. And we'll be outputting JSON. Pretty much expect everything to be using JSON. You'll be seeing a bunch of JSON blobs a little later, which I know everybody always loves seeing, piles of JSON, but that's where we are. Couple caveats I want to call out just real quick is Java parser, assuming you implement it well, which, as we all know, everybody in here always does. Should be typically, more efficient and better for higher volumes, whereas the grok parser is going to be a little better for lower volumes, but kind of quicker iteration. The caveat I would like to make is, a lot of the scaling effort and testing and so on is still being built out. So, your mileage may vary a little bit with this. You're going to have to play around with it to find a sweet spot if you get to that point. So this is really what the enrichment and threat intel looks like actually when we get under the hood. I would have had a slide for the parsing bolt, but nobody wants to see a slide that is spout, normalize, output. Very simple. Enrichment and threat intel is a little more involved. Like we were saying before, we have an enrichment topic just sitting on Kafka. That will go to an enrichment splitter that will essentially split out to different enrichment bolts that are each doing their individual jobs. For each individual enrichment, it'll actually run the enrichment just for that piece. Eventually, these will do a streaming join back up with a joining bolt, and we will kick off to threat intel. The enrichment bolts right now typically read from HBase. That's the main thing, is your enrichment data has to be available in HBase in some form, whether you're streaming it in or bulk loading. Bulk loading is useful for getting an idea of what's happening, but in a lot of cases, your data is going to be changing that you want to enrich with, so you're going to want to be pulling it into HBase, which however you want to get it in there in a usable format, it's kind of up to you. There is a loader framework for bulk loading some of this stuff. And then this mirrors a lot actually in the threat intel. Same type of deal. There's splitter, we go to bolts that handle each one, and then we join them up together. Again, this is stored typically in HBase. There are a lot of plans to make each of these kind of things configurable, but baseline is kind of this. Afterwards, we will actually just write this out to Elasticsearch and Hadoop. And one of the things to note is the enrichment bolts. You don't want to be making calls to HBase for every single thing that goes through if you've seen a lot of this information before. So these bolts actually do cache things. The goal is to avoid, even HBase can be hammered too hard if you are just throwing everything at it in a streaming context. So enrichment, like I was saying, a lot of this we've covered before, but it's really about just adding additional information. And if we add this information during streaming, that's going to allow us to actually score ML models in real time, because our machine learning models, we're actually going to want to be based on all of the information we have available, not just the individual pieces that sensor actually picked up. There are several enrichments available. They are kind of in varying stages of completeness and readiness, I would say. So like there's geo-IP enrichments for getting geographical information off of your stuff. Threat intelligence, like we were saying, essentially boils down to being enrichment in a lot of ways. And there's some host enrichments for pulling off all of the hosts and related machines for your network and being able to make sure that they're kind of tied to the pieces of information you got. I believe, and someone might have to correct me if I'm already wrong as of 2.0, that the host one is like not quite available through HBase. So if you want to use that, you're going to want to actually do a little bit of research into it and make sure it either is at the point where you need it, or I am sure everybody would be happy for your help to get it to the point where it's usable. Threat intel, like I said, basically the same thing. There's one main difference is in practice, you're going to actually want to use a threat feed aggregator. There's a couple like adapters provided, and there's like a flat file loader for if you want to like blacklist things just to get everything tied together. This is going to be in about 10 minutes a do what I say, not what I do type of thing for the point of this demo, or kind of just the little walkthrough. But basically, you're pretty much going to want this to tie to a real threat feed aggregator that's actually providing you regular updates, regular data, because otherwise you're just going to fall behind again. The Metron JSON, like we were talking about, what kind of gets passed around, there's a whole set of major fields. It's pretty much what you'd expect to need from kind of any normalized structure. We want to know, where did this come from? What, where is it going to? What protocol are we actually like hitting? For instance, the network on. When did it occur? What sensor did it actually occur from? And kind of when did we actually deal with processing it? You'll kind of see this being passed around fairly often. It's just good to have a baseline of this is really what you need to be able to handle some of this stuff. I'm going to talk briefly about PCAP. I'm not really going to dig into it a whole lot. There's a standalone storm topology for that reads from Kafka, it writes to HDFS, and there is a REST PCAP service that when you actually kick off a Kibana query, it will go to the back end, kick off a MapReduce job, and deliver the results to Kibana. And it pretty much looks exactly like I described. So for instance, from a DK probe, makes it to the topic, makes it to the actual storm topology, goes into HDFS, and we start querying it based off of our queries. There's some additional like replay capabilities in here for actually, when you've seen an anomaly, you may want to replay all your packets to kind of get a better idea of how different things act or different models act. That is actually available in here. So we are going to kind of trace essentially from a very, very basic, easy to understand source. Like I said, this is kind of the hello world of this to some extent, through to Elasticsearch. So we're basically looking just, first step is we want the sensor to go, make it through normalization, make it through the parser. And we're basically just going to use Squid for this, which nobody probably cares about for the past several years. But it has the extremely nice property of I can easily explain it right there, look at it, and give you, what the breakdown of these fields are. You can look at it human readable. Even if you didn't know what they are, you can probably guess almost everything that you actually need from here just by looking at it, rather than me having to explain an unmanageable, unparsable log within a couple minutes. So like we were saying earlier, we're going to build a Grok parser for this, and it's real simple. It looks pretty much like a regex, where we pull out a couple things we want that we saw from the earlier JSON blob, like the timestamp, the the IP source address, the IP destination address. We give this a name so that we can actually refer to it later, but otherwise we kind of keep the individual fields around. So we keep the code, we keep the number of bytes, we keep what URL was actually hit, and we drop a couple miscellaneous things that we don't actually care about. For instance, we don't care that the type was text/HTML. So we basically call it unwanted and discard it. For this, it's a pretty straightforward parse just because it's a very simple log. So the topology definition, which apparently got a little mangled on the screen here, is we are basically using a Grok parser. We're saying we're going to be using the Squid topic. We're saying, this stuff lives in HDFS, and it's at the Apache Metron pattern Squid. There's a whole set of these patterns that actually come with kind of built into Metron. So this includes like bro, YAF, a couple other things. We're pulling out the timestamp field, and we're actually doing a couple minor transformations on this. So for instance, we're removing subdomains. There is a set of these type of minor transformations in the Stellar DSL language that are made available to assist in these type of transformations, make things easier to do. And they're all kind of documented online. It's very much common operations that you'd expect, which is very nice. So what this actually looks like, there's a step here that I cheated on, which was basically, actually I lied, I skipped that step a little later, I cheat on. But we basically just load up this parser and topology into Metron. We let it run over a few records, and this is an example of one of the records it pulls out. So it keeps things like the host name, we see the code, the method, all the type of stuff that we saw in our sensor logs. There's a few timestamps added from Metron. We keep some URLs, and we pull out things that I called out a little earlier, like the IP source address, the destination address, and so on. So, and one final thing I want to call out is we actually keep the original string. So we keep the raw data right there so that you can look at it with it, which is nice to correlate, especially if you've made a mistake or you suspect something. There's always the possibility that whether you're defining a Java or a Grok parser, that you may still have to go back to this original source. And like we said before, we discarded a couple fields. So you could potentially go back, say, why didn't we catch something, look at this and say, oh, we shouldn't have been discarding that field, we should have kept it. You can adjust and carry it through. As a note, if you do something like that, these configs are all maintained in Zookeeper. They will be picked up on the fly if you push these things back up, so you don't have to have a downtime to restart a topology and things like that. So moving on to enrichment, we're kind of looking at the first kind of section of this. Like I said earlier, thread intel is going to be very similar to this. So that'll probably be a little abbreviated. In this case, we're loading some whois derived data. We are not directly making a whois query. We basically just pull this into a CSV containing a few rows. Like I said, this is the hello world version of this, not the I'm doing it for real version of this. So that CSV is basically just loaded into HBase. I left that out because it's not particularly relevant to Metron. Like I said, it's however you get things into HBase in a usable format is pretty much what matters here. So we're basically saying we want to call this sensor, we want to call this whois. It'll basically look up based on our domain name what we actually have here. So pulling these enrichments out, the very first thing you can see is for NBA.com. We have, the owner of it is NBA Media Ventures, and there's a couple other of these strings that actually get pulled through. So like the home country being the US, the domain created date, the registrar. These are basically the fields that we pulled and exposed from the whois data. If you're doing this in a more robust manner, you really want to parse the whole whois response and actually do something a little more meaningful with it. But this kind of gives you a good idea of what this actually looks like when you're passing things through in terms of an enrichment. So this may, like I said, there's other kind of some built-in enrichments for like geo-IP data. Otherwise, you may want to build in your own to correlate with your own data sources. To correlate with whatever your network machines look like, what kind of just other kind of similar things. There's also some tools for like doing some filtering and so on. I should have probably mentioned that like a slide ago, because you may not necessarily care about anybody hitting NBA.com if you work for the NBA, right? So there may be things you want to blacklist or that you want to provide, just filter out. We don't actually care about it. You don't ever care that that makes it to an analyst, because why would you ever care? Then, like I said, thread intel is basically very much the same thing. The JSON looks pretty similar. Basically loading a list of malicious domains via the Zeus tracker. This is just online. You can go download basically a list of just a whole bunch of known malicious domains. Again, it involves a somewhat hidden step to just load this into HBase, but we're really just saying that we want to actually figure out, did we hit any domains, were there any sensors that hit domains that, we know that are actually bad. So really what comes out of here is essentially just one field, is alert true, which means that, yeah, we actually hit this. I don't have anything kind of going beyond this, but there's also utilities for, I want to rank these threats. So for instance, if they show up in the tracker, you may want to give it, a value of 5, or you may want to, based off of what the domain looks like, if it comes from, like, say, one of the countries that was being hit for Drone Emix router, you may want to say something that comes from China or Portugal is a higher level of threat and be able to alert on it. Whereas you may say that something that comes from, your country or your local area, you may not actually care about as much. So I think that pretty much covers kind of the just basic what I wanted to go through. As always, I talk a little faster than expected when I'm talking publicly, so that gives everybody more time to ask questions, whatever they want. And we have like about 10 minutes actually, so does anybody?
How does
I'm not familiar enough with Eagle to answer that, quite frankly. I am 100% sure that if you find me afterwards, I can hook you up with the right people to at least be able to hopefully get a good idea of that.
Okay, thank you.
Yeah, absolutely.
How much throughput are you getting through your stroke problem?
So I don't have a good measure of that. Like I said, a lot of that is going to be scale tested. There's also things that have to be put in, like a lot of the Kerberos stuff has to tie together and so on. I don't know if a number exists. I can try to dig one up. Do you want to meet up with me afterwards, and I can get your information, and I can try to see what I can find for that. What's up?
Do you all consider adopting Apache Flake over Storm?
So my understanding is, and I wasn't there for this decision, is Storm, Flink, and Spark Streaming were all considered at some point, whether it was initially or being switched to. My understanding is it was a combination of scalability and stability concerns, kind of depending on which portion you're looking at. Like I know Spark Streaming, for instance, has only very recently been kind of stable, and I know they're still working on that. In addition to kind of scalability questions of that, I'm not sure specifically what analysis went in for Flink. And for that, Storm is kind of a known working, scalable quantity, I think is kind of what that boiled down to. What's up?
Is there any plans to do cloud-native versions of this using some different queue like SQS, Kafka?
Sorry, could you speak up a little bit?
So are there any plans to do cloud-native versions of this? So using dropping using S3 at the end, or going to SQS instead of Kafka?
I honestly don't know about that. If that's probably something that'd be good to ask the dev list, I think. I don't.
We try very hard to make it generic. It's extremely.
Yeah, that's a good point. Like I was mentioning earlier.
We have an EC2, usually the actual like SQS and S3, we try to use the abstraction differences of Hadoop. So hopefully we should be able to write out these things. We're not direct plans for that, but we also don't want to put that out.
Anybody? Yeah. Yeah, what's up?
So your architecture diagram showed 2 data flows.
Yep.
Elasticsearch, 1 to Hadoop.
Yes.
Does that mean you have 2 copies of the data? What are the purposes between them?
Yeah, there are 2 copies of the data. Like I mentioned earlier, the Hadoop stuff is, a lot of that is for historical analysis for building and training machine learning models. Kind of once that stuff rolls in, we want to actually be able to look over a large corpus of historical data. It's also useful in terms of investigations, where if we've seen or detected new anomalies, particularly based on whatever new models or investigations we've done, we may want to go back in time and see how far back were these things occurring. Because just because something looks like the first time you've been hit today, you may have been hit by similar things a month, 2 months ago, but you hadn't quite figured it out yet. So you may want to go back and do that investigation. The Elasticsearch is more for providing a pane of glass, kind of for your analysts and investigators to look at, to be able to quickly drill into data in a meaningful way. Because without it, you'd be querying Hadoop, which is, you can make some of this stuff fast, but that's not necessarily a usable way that everybody is familiar with. You want people to be able to run kind of Kibana-style queries to be able to get at this data, kind of drill down, build whatever, kind of dashboarding and so on you want. Any other questions? All right. I think we are all set. I'll be here for a few minutes if anybody wants to come up and ask anything, talk.